Good morning, class 9. Today I'll discuss with you the graphical representation of motion. Motion, as you have understood, that is moving bodies. How the graph is being represented of any moving bodies. So here I'll show you. Just see. First of all, graph. Graph, I think you know how to draw it because you have studied in standard 8. Graph is the pictorial representation of the variation of two physical quantities. Whenever you are representing graph, I think you know we are drawing two axes, x-axis and y-axis. I have shown you x-axis, y-axis. This is the origin. Right side of the origin is positive x-axis. Left side of the origin is negative x-axis. This is horizontal line. So horizontal line represent x-axis. This is vertical line. Vertical line represent y-axis. If you go just above the origin, you will get positive x-axis, and if you go below the origin, you will get negative y-axis. Above it is positive y-axis, below it is negative y-axis. Now the thing is that how we choose the scale, which one will be x-axis and which one will be y-axis. Very common example I am giving you. All of you are seeing cricket. In cricket match, if we draw the graph of score versus overs, which one we will choose over and which one we will choose score. So, first thing try to understand. X-axis always indicate independent quantity. Y-axis represent dependent quantity. Let us see score and overs. Number of over is independent, but number of runs, that is score, is dependent. So independent is number of over. Over is represented on x-axis and dependent is number of runs. Runs is shown in y-axis. Like this we are choosing our x-axis and y-axis. Now I'll show you the distance time graph. So let us start with types of graph, and first type is distance time graph. A moving body changes its position, and if the body changes its position, that means it covers some distance. So let us start. Again, I have drawn x-axis, I have drawn y-axis. Dear students, you please do all this thing in graph paper. X-axis, just you see, I have taken the time 5 seconds, 10 seconds, 15 seconds, 20, 25, 30 seconds because time is independent. Time does not depend on anyone. Distance depends on time, so distance is dependent. So it is chosen on y scale, y ordinate, and time is chosen on x ordinate. Just you see, this line shows a slope. This is known as slope. So slope represents speed of distance time graph. How will you calculate the speed? Speed is distance covered by time taken. Let us take any of the time. Suppose I have taken 5 seconds. For 5 seconds, body travels 2 meters. So speed is equal to distance by time. OA, distance travelled. OC, time taken. 2 by 5, that is 0.4 meter per second. Like this, we can calculate the speed from distance time graph. This graph is of uniform motion because its Slope is straight line. At every time, every seconds, you can calculate the speed. Every time you will get 0.4 meter per second. Next to come, when body is moving with non-uniform motion, I have given you one question, that is when time is 10 o'clock, distance covered 0 meter. When time is 10:30, distance covered 20 meter. Time is 11 o'clock, distance covered 40 meter. Time is 11:30. Draw, first of all you draw x-axis, then you draw y-axis. Draw in graph paper. This time interval, according to the data, we are doing it. So I have shown you first 10 seconds, 10:30, 11 o'clock, 11:30. At 10, the body covers 0. So at 10, the body covers 0. It should be here. At 10:30, the body covers 20. So you see it is 20 at 10:30. At 11 o'clock it covers 40. So at 11 o'clock it covers 40 and 11:30 it covers 45. So 11:30 it covers 45. Join all the points. You have not, now you see you have not got the slope as a straight line. So for non-uniform motion, slope is not the straight line. Speed does not shown in straight line. How we calculate the speed from this graph? Suppose question is given, calculate speed when time is 10:30. We know speed is equal to distance by time. When time is 10:30, the distance covered by the body is 20 meter. So 20 by 30 minutes. See the differences between 10 and 10:30, 30 minutes. So change it into seconds. We have got 20 by 1800 seconds. That is 1 by 90. That is equal to 0.01 meter per second. So like this we are calculating the speed from non-uniform motion. For non-uniform motion you can get the graph like this also. Any type of graph, but it is not the straight line. And last one, let us consider when body is at rest. Now suppose body is at 10 meter. This is your distance. This is your time. This is represent distance. When no time is 0 second, body is at 10 meter. Again you see when time is 1 second, the body is at 10 meter. Again you see time is 2 seconds, the body covers 10 meter. That means what? Time is moving on, but distance, that is position, is not changed. As position is not changed, the body is at rest, means one position only. So this is the graph which shows the body is at rest. Slope is parallel to x-axis. Okay.